Robot Talk is the podcast that sits down with robot enthusiasts from around the world and asks them the questions you always wanted answered. Like, can robots help us explore the ocean? And how does that thing work? Hello everyone, welcome to Robot Talk. I'm your host, Claire Asher, and this week's episode is about underwater robots for exploring and collecting data about the deep ocean. But first, I'd like to remind you to rate this episode and leave a review if that's something you can do on the platform you're listening on. And don't forget to share the podcast on social media or tell your friends about it. It really helps the podcast reach more listeners. So, without further ado, I'm excited to introduce this week's guest. I recently had a fascinating conversation with Joe Wolfel from Terradepth about autonomous submersible robots for collecting ocean data. Today, I'm talking to Joe Wolfel, CEO and founder of Terradepth, a company developing ocean-going robots to collect data on the marine environment. Hi Joe, wonderful to have you on the podcast.
Great to be here, thanks.
So first of all, what inspired you to found Terradepth?
Really, it was my experience in the Navy. I was in the US Navy, and I was a Navy SEAL, and you learn a lot about the ocean when you're lost in it. And
yeah, I imagine so.
Getting a bit thrashed. And so actually, in 2005, my eventual co-founder and I were getting ready to go on a deployment that was actually far away from the ocean. But we did hear about a US Navy submarine running into an underwater mountain.
Oh, wow.
And at the time, we were learning to use this new thing for navigation called Google Earth, eventually Google Maps. And we said, well, on this Google Earth thing, we can see the bottom of the ocean. So one, why are we so lost when we go diving? And two, how are US Navy submarines with nuclear reactors on them running into underwater mountains and stuff?
Yeah.
And that's when somebody said, hey, genius, we actually don't know much about the bottom of the ocean. And this is all extrapolated data, mostly from satellites. And we essentially filed that away and went off and did our careers in the SEAL teams and really had an opportunity to start something special when we got out based on a network that we made, relationships that we had in place, and there was some funding available to start something that really did something important from a technical perspective.
Yeah.
So one, there was opportunity, and two, Judd Kaufman, my co-founder, and I had a lot of motivation to actually do something very positive for humanity and continue our tradition of service on the outside in a non-military context. And we thought, what better way to do that than help people make better, faster decisions about what we do and don't do in the ocean, because it's the vast majority of the planet.
Yeah, absolutely. And I guess your experience in the Navy meant that you really understand just what a harsh environment the ocean can be.
Yeah. There's no GPS. Light doesn't work very well. So in a lot of ways, we were flying blind and we are flying blind today. There hasn't been this rotation of technology into the maritime environment that you've seen into space, for example. And there's a lot of reasons for that. Physics and economics, mostly, as most things go in the world.
Sure. So tell me a bit about the fleets of autonomous underwater robots that you're developing.
Yeah, so one of the major reasons we don't know much about the ocean is because we simply haven't mapped it. And the issue with mapping the ocean at scale is, again, one of physics and economics. It's just very expensive to collect high resolution, deeper ocean data. And the reason that is because of signal attenuation in the water.
Right.
We can fly as many satellites as we want to, and all that energy that those satellites are using to essentially generate imagery, it gets absorbed or reflected very quickly in ocean water specifically.
Right.
So really the issue is, how do we collect data at scale, reducing human exposure risk and reducing the amount of capital required to go do that? So today, when we do ocean data collection operations, we have a big ship. We've got very expensive robots. We put people on the ship. We put the robot over the side. We let it go do its thing like a Roomba. We hope it comes back. And then once it's on deck, we pull the batteries out. We put fresh batteries in. We pull the data off. People on board the ship start processing that data so that they can do quality assurance. They can retask the robot. And we put it back in the water and we wait for it to come back. So you can see how expensive all of this is. And it's this very point and a model. We care about this part of the ocean. Go map that thing so we can make decisions off of it.
Yeah.
What we're trying to do with these robots is essentially minimize or remove that requirement for humans to babysit that robot. Mm-hmm. And so what that means is we've got to be able to replicate what that ship and those humans are doing fully on board the robot. So essentially what we've created is a self-recharging drone capability that can be mutually supportive. So if we can have subsea drones that can go out, map the ocean, they're smart enough to do it without a bunch of human intervention, and then they can recharge their own batteries while supporting each other from a positioning perspective, which I can get into if you want, because that's something people don't realize as far as how this all goes. Then we can start getting rid of that surface vessel that's babysitting the robot. And we can have fleets of these Roombas out there just doing their thing. All that data comes back to our cloud architecture. And then you've got a high resolution map at a cost people are willing to pay for.
So yeah, I mean, tell me more about the localization angle.
Yeah. So, essentially what we need the ability to replicate what that ship is doing. So that ship's doing three things. So one, it's providing an energy recharge capability because humans are putting batteries back in. Two, it's providing a data processing capability because you're literally taking data off via cable, putting it on a laptop, processing it, understanding it, and then retasking. But the third thing it's doing, to your question, is the ship is providing its GPS location, GPS derived location, to the submerged asset, which does not have GPS. So these submerged assets are all operating on inertial navigation and some acoustic relay. So basically the ship's saying, I'm here based on my GPS reading, based on the angle and distance to an acoustic ping that I send down to you, robot, you must be here now, because the inertial navigation systems aren't perfectly efficient. So there's drift across time. And that's what essentially recalibrates that localization piece for the robot.
Inertial navigation, is that just based on how far you think you've moved, based on like the water moving past you or whatever?
That's right. Based on pitch, yaw, speed, a bunch of measurements essentially that get filtered out saying, we think we've gone this far. It's like dead reckoning.
Yeah. Okay. So
the company's first patent is called single variant dual purpose data collection capability. And there's an autonomous piece in there somewhere, but it's a mouthful.
Sure.
But essentially what we've done is said, look, instead of having this big expensive surface ship, I'm just going to have two robots that are the same. And so they operate like a Navy SEAL swim pair. So I've got one on the top, it's snorkeling, it's recharging its batteries, it's parsing, prioritizing, processing data, and sending snippets of interest to a remote human operator. And it's taking its GPS location and transmitting that to its submerged twin that's underwater doing a high resolution data collection mission, just normally on battery. But when we run low on battery power underwater, we just flip. And so what that allows me to do is essentially leapfrog through the water column, which enables me to get actually more data than just the seabed, because now I can get volumetric data, water quality, chemical, environmental DNA, things like that. And it really allows me to start crushing the cost out of that entire operation, because I've got one bill of materials, I've got one sparing plan, I've got one maintenance plan, as opposed to having these disparate assets that I've got to go figure out the supply chain for, which is pretty wonky in maritime anyway. And I can really start getting down to orders of magnitude less on an ocean data collection operation.
Yeah, that's a really ingenious solution to the problem. When you explain it, it seems quite obvious. But I'm sure it's not. Otherwise, other people would have done it before, right?
Well, It's funny, right? Maritime is very conservative, and they're conservative for a reason. I mean, it's rules have been written in blood for centuries. The UK has done probably more than any other country in the maritime space and done a lot with sea power. And it's conservative for economic reasons. The depreciation cycles on these ships that people are putting to sea to collect ocean data or do work are decades long. And so it creates this, the maritime industry is always interested in technological innovation, and there's brilliant engineers, but there's a lot of economic disincentive to move quickly in that regard based on the capital asset base that's already there.
Right.
So when we took this, it was, again, me and my co-founder were, commandos who have good ideas sometimes, or so we think. We took it to some folks that we knew at MIT, Massachusetts Institute of Technology, who do this type of stuff. And we said, hey guys, we got this idea. What do y'all think? Why hasn't anybody done this before? Because it's very simple. And the initial response was, well, you two are just dumb enough to have found something that may actually work. So there's a certain amount of domain ignorance that can be required to cut through decades of brilliance.
Yeah, sometimes it just takes someone who's kind of outside of it to see the solution.
Right.
We have an audience question submitted by John on LinkedIn. So John says, what is the biggest challenge when it comes to developing submersible robots?
Great question. They are manifold, but the biggest one, honestly, is it's capital risk.
Okay.
At this point. And specifically in our case, we are not building robots to essentially mark them up, make them really expensive, and sell them to a foreign or, in our case, US government. And that's how a lot of this goes right now.
Yeah.
Make something really expensive. You don't really care about reliability because I'm just going to sell you a maintenance contract on the back end of it anyway. Right? Or I'm going to make something really cheap and sell it to a university and try and do that at scale. Yeah. So there's a very manufacturer-centric approach to this. It's a heavy engineering-centric approach. So you get these exquisite, amazing capabilities, but they're good for a thing.
Yeah.
And they break a lot. So what we're out to do is, create I don't know if this will resonate with UK folks at all, but essentially the Model T of autonomous underwater vehicles, right? A cheap, scalable, autonomous underwater vehicle that's going to work good enough for commercially and governmentally, conservationally relevant data. And we're going to build a lot of them, and we're going to operate them, and we're going to be heavily incentivized to make sure that operation is reliable, quality, et cetera, because we bear the cost of that. So getting over that hump has been difficult from a capital perspective. I think we're there. But this is why you don't see a lot of startups in maritime. Everything's expensive. A thruster is $150,000.
Wow.
And that's just one little piece of the robot.
Yeah. That's interesting. I was really expecting the biggest challenges to be like, engineering, technical challenges to do with the ocean environment, not like, financial, economic concerns.
Those are definitely there.
Yeah. For
sure. But there's been a lot of very smart people doing a lot of very good work around that. And a lot of, I think, the physics issues that you run into just based on signal attenuation in water and localization problems. Again, they're manifold, but you can overcome a lot of that with scale. And getting to scale requires the application of economic leverage.
Yeah. That makes sense. So as you've said, the ocean is one of the last kind of real frontiers of exploration on the planet. And you've mentioned a little bit about kind of collecting data about, I guess, the actual structure of the sea floor. But what other kinds of questions do you think you might be able to answer with the ocean data your robots are collecting?
For sure. You've got the current economic drivers are around, is there something there? is there not something there? Can we put something down on the ocean floor? Should we pick something up off the ocean floor? Or what's the condition of stuff that we've already put down there?
Right. Yeah.
Inspection, maintenance, repair, right? So pipelines, high voltage DC cables, submarine fiber optic cables, all the power export coming off of offshore wind projects, et cetera. In a lot of cases, it's a tube that moves something valuable through it. Communication, oil, gas, electricity, et cetera. The reason that a lot of data collection operations are constrained to those types of data sets, like unexploded ordnance, nobody wants to go put an offshore wind turbine. There's 1.2 billion tons, I believe, in the North Sea.
Wow.
Of unexploded ordnance that we know from World War II.
Yeah, that's scary.
Yeah, it's not like this is a small problem. So people are willing to pay for that. I think the biggest opportunity that we have is if we can drive the cost out of these data collection operations, do them at scale, do them persistently, you're going to be able to do two things. One, you're going to be able to collect data sets that tangentially that people aren't willing to pay for right now. So like environmental DNA. But what if I could classify, quantify essentially a voxel, a cubic meter rather, of seawater?
Yeah.
What organisms are in it? What's the salinity? What's the temperature? All these things. If you can start doing that and combine that with high resolution seabed data, now I can very accurately start modeling climate change and then derivative weather patterns from that. And that's got a massive impact to coastal regions of which a lot of people live near. You're seeing it happen, at least on the US side of the house right now, Nantucket, Florida, places like that. Yeah. So that's one piece is I can get derivative data sets that right now are tangential or of interest to, for example, the conservation community. There's not the capital there that there is on the commercial side of the government side.
Yeah, absolutely.
So that's one piece, is extending the types of data and then really cross-leveling that to a wider group of stakeholders, because one thing we know, and war is a terrible thing, but you do learn things from it pretty quickly. And if you don't, you're not around very long.
Yeah.
One of the things you learn is that when you're dealing with complex problems and complex, chaotic ecosystems, the only way to make good decisions is to get the same amount and type of information to a very diverse group of stakeholders, such that that group understands a problem so intuitively that you can start making good, fast decisions. And that's what we're trying to do across the board. So that's the first piece. The second piece is being able to do change detection across time.
Yeah.
Because these data collection missions are so expensive, you're going to do one of them, then you're going to go, great. Now we know we can put that wind turbine down there. We can drill for oil there. We cannot drill for oil there. Should we mine the 16 trillion of rare earth minerals? Should we not? Maybe we know, right? The only thing that's going to save us is the ability to revisit the same place on the planet so that we can understand what's happening or what's not.
Yeah.
And right now our in is one in a lot of places.
Yeah.
So that's the second piece, would be just change detection of geographic locations on the planet.
Yeah, the possibilities seem kind of endless, really, when you start kind of being able to collect this data at scale and over time.
And that's actually perfect. That's the third piece that I didn't mention, which is I don't know.
Yeah.
I really don't know. And I don't think anybody knows, because it's tough to talk about an unknown.
Sure.
But we know that by being there, we're going to find stuff.
Yeah, that's really exciting. That links quite nicely in with another audience question we had submitted by Marianne on Patreon. So Marianne says, what unexpected discoveries or surprises have you encountered while developing or deploying robots for ocean exploration?
The prevalence of underwater caves that you can't get a robot out of.
Oh, gosh.
That would be one. We still got a robot sitting in deep storage at 700 meters in a cave.
That's quite sad.
it's as you start mapping, you start to realize there's just a lot more down there than you think. Right. I
Yeah.
think, one of the issues we face a lot, again, from a capital perspective, sometimes is people are like, we already know what's down there. Let's go explore this space thing. There's all this, all these stars. Oh, we don't know anything.
Yeah.
And so I think it's just surprising what you find in general when you've got a high resolution understanding of a spot on the planet that potentially nobody's ever seen before.
Yeah. It's funny. I think a lot of people assume that with all the technological developments we have now, that we must have been down there and had a look.
Yep.
And it's quite surprising that we haven't.
Yeah, when you get on Google Earth, you can zoom into your house.
Yeah.
You get on Google Earth or Google Ocean, which was an initiative which is still going. But you start drilling down into the seabed, and then eventually you get to 5, 10 places on the planet, and there's a static picture of dolphins. That's it. Right?
Yeah.
Because again, the data was so expensive to collect in a lot of cases, it's sitting on a hard drive in some company's closet or a safe, right? We're trying to unlock that latent value of the data too. I mean, it's not robotics centric per se, but the other piece of the company is we've created a data and software architecture that makes it really easy to upload, download, visualize, share, collaborate with, or keep secure ocean data holdings, whether or not we collect them.
Okay.
Right. That's the other piece is you've got to really radically improve that user experience with that data, because I think we probably have mapped more of the ocean than we think we have. We just can't find it.
Right.
In a lot of cases, people just delete it. It's just too much effort to go through a closet full of hard disk drives or magnetic tape. We've seen that before.
Oh my gosh.
Yeah.
Do you think that eventually you may need to deploy some kind of like machine learning to start analyzing the just vast amounts of data you're collecting?
Yeah, we already are.
Okay.
So I try to avoid it because, everybody's got an AI angle right now.
Yeah.
But it is a fundamental aspect of what we do, and it bridges the hardware and the software. So we're running machine learning model ensembles on-prem on the robot right now, essentially to say, okay, look, is this an object of interest or not? And so those are the snippets that we pass right now. And we're looking for man-made objects. And so we run 2 separate machine learning models on that right now. And then on the data platform side of the house, you can bring your own machine learning model and run it against whatever data holding you've got. So it is a bridge. It is a backbone between the disparate areas of innovation of the company. We kind of view it like electricity, right? It's not a thing. It's something that you use to go do something.
Yeah, absolutely. When you're dealing with this amount of data, it's too much for humans to do on their own. Yeah,
and it's different data, so a lot of the higher end military drones are spinning off 2 petabytes, which is just an insane amount of data on a mission.
Yeah.
We're spinning off about 1 terabyte, but these data are not necessarily easily human readable. Right? It's not like that's a person, that's a tree, that's a truck. It kind of looks like a mess sometimes. And you've got highly trained people who are, one of my guys like, that's a swordfish. And it just looks like a bunch of pixels to me, right?
Yeah.
So in that instance, machine learning and computer vision can really help you.
This makes me think of the kind of the interactions you are going to have to deal with wildlife. I imagine, especially in the deep ocean, there's a lot of scary organisms down there that may not appreciate your presence very much.
Yeah, we think we got a shark bite once.
Really?
Yeah.
Wow.
I mean, it's some of the robots we launch are small and yellow, and it looks like a tasty fish. But it's tough to know.
Yeah.
What I will say though is from a marine mammal protection standpoint, or a large fish protection standpoint, the benefit that we have is that we fly relatively close to the seabed, and that's what gets us that high resolution imagery, for lack of a better word. Whereas if you're going to do an ocean data collection operation and you don't want to pay for a robot, you're using a surface vessel. And those are good because you've got really good positioning. You've always got a GPS fix. But to get high resolution data from the seabed, and we do this mostly acoustically, you've got to pound that water column with sonic energy.
Yeah.
And so there is a concern that, not a doctor, but I'd be willing to play one on TV. There are issues with cetacean embolism.
Yeah.
Right. So if basically you've got a whale that gets between that head, of the acoustics coming out of the ship and the seabed, that can cause issues. These are very sensitive creatures.
Yeah, of course.
The chance of a whale getting, sandwiching itself between our robot and 10 meters of seabed or water to the seabed is very unlikely, and we just bounce off the thing anyway.
Yeah.
So there is an edge to the type of data collection we're talking about, just from a wildlife safety perspective, for sure, and that's important.
Yeah.
I know on the East Coast of the United States, right whales are a huge issue for, just normal ship traffic.
Yeah. We're polluting the water with so much sound as well as anything else that we're polluting it with.
Right.
Joe, it's been really fun chatting to you today. I've been speaking to Joe Wolfel from Terradepth. Thanks, Joe.
Thanks so much. I appreciate it.
Thanks for listening. If you enjoy Robot Talk, please share the podcast, subscribe, and leave a review. And make sure you check out @Robot Talk Pod on social media to see a photo of Terradepth's self-recharging Subsea robot. Next week, I'm chatting to Minnie Rye from Orbit Rise about robots in space. Until then, I've been Claire Asher, and this has been Robot Talk. Robot Talk is brought to you by the Hamlin Centre, Imperial College London.